Valency, when we talk, if we talk in terms of number of hydrogen atoms or double the number of oxygen atom, let's understand this. Suppose we have structure of ammonia. So how many hydrogen atoms combined with nitrogen? So three hydrogen atoms, they combine with one atom of nitrogen. So valency of nitrogen will be 3. Let's talk about the next concept, which is radicals. Like in valency, we talk about an atom. Radicals, whenever we talk, it could be an atom or group of atoms of same or different elements that behave as a single unit with a positive or negative charge. It could be positive or negative charge on it. For example, if I say, just now we did the valency of sulfur, we had charge as -2. So valency of sulfur here is 2. Same way when we talk about the radicals, suppose ammonium. So we can't say nitrogen, hydrogen. No, we have to say NH4 plus. So here we have an atom and here we have group of atom. Same way, just now when we did about cations, the other name for cations is electropositive radicals. So that means what it conveys? It will have positive charge on it. And just now we did the other name for it is cations. Let's talk about the next thing. When we talk about the electronegative anions or radicals, when we talk about electronegative radicals, that means we are talking about anions, means having which charge? Negative, sulfide, chloride, and so on. Now let's talk about the next thing, formula. What is formula? Symbolic, means we have to write the symbol, we can't write it in words. Representation of a molecule, that's a formula. For example, if I say carbon dioxide, carbon, oxygen, and di means 2. So this is formula. And how we calculate valency from the formula? Let's see the method. Let's write down this formula. CO, we have written. Now what we have to do? We have to see the valency of oxygen, or the other method could be, let's write down the formula CO2 and let's change their subscripts. Since it has 2, so 2 will go here, and it has nothing means it has 1, it will go here. So let's change it. C will get 2, O will get 1, right? Now what is the valency of oxygen? It is 2. Let's write it again. 2, 1. So multiply both the numbers with valency of oxygen. 1 into 2, 2, and 2 into 2 is 4. So what we get? C4O2. So what we conclude? Valency of carbon will be 4. 2 though we already know, that of oxygen. Now let's talk about next thing, that is chemical equation. Before talking about chemical equation, let's see what is a chemical reaction. If I say magnesium burns in air to form magnesium oxide. So what I am doing, I am writing that what is happening in a chemical reaction. So this is called as chemical reaction. But if I write it in the form of symbols, so it will be chemical equation. So symbolic representation of a chemical reaction using what we have to use, symbols and formula, right? So let's see how it is done. Symbol for magnesium, just now we did. Magnesium burns in air means plus oxygen to form magnesium oxide, so MgO. If you look at the equation, number of magnesium atom this side is 1, oxygen is 2, this side magnesium no number means 1, oxygen 1. Such an equation which is not balanced is called Skelton equation, where the number of atoms are not equal on both sides. This side we have 1 and 2 and that side we have 1 and 1. Now let's see how to balance this and what is a balanced equation. Magnesium plus oxygen MgO. So how many magnesium atoms on left hand side? 1, oxygen 2, this side magnesium 1 and oxygen 1. So magnesium atoms are equal on both sides, but this side oxygen atoms 2, this side 1. One method is you simply interchange the numbers. So what do you have to do? This side it's 2, this side 1, so put 2 here. This something which is alone can be balanced in the end. So when you exchange, that's just a trick. We get how many magnesium? 2, and we get how many oxygen? 2. So we count it like this. 2 ones are 2, 2 ones are 2. So this side oxygen 2, this side 2. So this is balanced. This side 2, this is magnesium 1. So put number here. In balancing, we cannot put any number as a subscript. We have to put the number in the front. So how many magnesium atom? 2. So this equation is balanced. So this is called as balanced equation. Something which we write on the left, they are called reactants. So what will be the definition? Substances taking part in the reaction. They will react and you will get the product. Right hand side, if you look at this product, substances formed during the reaction, formed in the reaction or during the reaction, whatever you want to say. In a reaction is better. So next thing, when we talk about the reactants and products, let's see it on again. So this was the equation. So these are reactants, these are products. Which side we write them? Left hand side. This side is right hand side. Suppose you want to make coffee. So what will be the reactants? Milk. Then what else? Sugar, coffee, plus you need something to heat it, right? And this side, what is the product? That's the coffee. So this way we talk about reactants and products, and how they are separated. They are separated by an arrowhead, right? So when we talk about the equations, we talk about the equations like this. So this method which we did, that you write 2 here, you write 2. So you are doing actually trial method. So the name of this method of balancing is called hit and trial method. Now if you look at equation, just see Mg plus O2 is MgO. Mass of magnesium is 12. Oxygen is 16 into 2, it's 32. Magnesium is 12 and oxygen is 16. The total of this side is 28 and this side it is 12 plus 32 is 44. They are not equal. So that means why we balance. Now the question comes, why we should balance? We should write the equation when the equation is not balanced and when it is balanced. So what numbers we were getting in skeleton equation? This side 44 and this side 28, which are not equal. Let's balance and write 2mg plus O2, 2mgO. So 2 into 12, 24, 16 into 2, 32, 2 into 12 plus 16. So 2 into 28. So it's 56 and this side also it is 56. So why we balance equations? To satisfy law of conservation of mass.